So now slotting in the values, our ultimate load UL will be equal to 1.35 multiplied by 1 on 2 multiplied by NDL, which is the dead load of the slab, so 7.1 multiplied by the short span. So for panel C, the short span is 5,800. So multiply by 5.8 into bracket 1 minus 1 on 3 multiplied by K for panel C, which is 1.12 squared, plus the self-weight of the beam, which is 0.25 times 0.45 multiplied by 24 plus 1.5, which is the partial factor of safety for life load or variable action, multiplied by 1 on 2 multiplied by NLL, which is the life load of the slab, so 2.5 kilonewton per square meter multiplied by the short span, which is 5.8 again, into bracket 1 minus 1 on 3 multiplied by the K squared, so 1.12 squared. And if we work this out, we have a UDL with magnitude 31.1 kilonewton per meter. So sketching the beam loading, we would have this. So we would have a UDL with magnitude 22.7 on beam A. Again, for beam B, we have a UDL with magnitude 24.9. And then beam C, we have a UDL with magnitude 31.1 kilonewton per meter. So now we are going to head on to Python to write some codes to do the calculations for us, such that whenever we change the beam dimensions as well as the spans and the loadings on the slab, the code will be able to calculate the beam loadings for us. This will also be an interesting one, so stay tuned till the end. Save. So I'll now launch my Anaconda Navigator and we'll be using the Jupyter notebook. So this one, I'll click on it once to launch. So once it's started, you can create a new file. You head on to the top right corner here. You click on the drop down list and you select Python 3. Click on it once. To start off, the user would have to input the parameters of the design. So we are going to write a heading here and call it input to know where the section where we are supposed to put the input of our design. So we will click within this cell once and we'll go to the drop down list here and select heading and then click on this OK, and then we can write input and then shift enter. Right, so that's our heading there. To make our work easier, we are going to import the sketch we are working with or our design parameters into our Jupyter notebook. So to do that, within this cell, make sure you select the markdown option here. Click on it once of your parameters as well as the sketch. So to do that, you do the print screen. Click on that and you can select your design parameters and then you head back to your Jupyter notebook. Click within this cell and then you right click and paste. Once you have the image there, you do shift enter and your design parameters will be shown here. Now we'll start with the coding. So first of all, we are going to input our parameters as we've indicated here. So looking at our sketch, we would need the slab thickness. The user must be able to again enter the dead load and life loads of the slab panels, as well as the cover to reinforcement, and then the beam dimensions. Again, the user must be able to enter the dimensions of the panel, so the LX, the LX, and the LY. So to do that, we would start off with the LX. So that is the short span. So we are going to write LX equals, so we are going to use a range for that, and to do a range, do two square brackets. So our first span, that is for panel A, is 4,500 and panel B is 5,000 and panel C is 6,500. You can enter it any way you want it. Later on, we are going to write the code to sort out and print out the long and short span, where the long span is the maximum value of the Ly and the Lx. So for panel A, the short span or this horizontal span here is 4,500. So we can do 4,500 and then a comma. The next span is 5,000. That is for panel B. The next span is 6,500. So that is for the short span or the horizontal dimensions. Now we're going to do the vertical dimension. So that is for LY. So let's call that LY. And again, we are going to use a range for that. So Ly will be equal to square bracket. And then so the Ly is just 1 here. So it's 5,800. So we are going to repeat it 3 times because panel A, B, and C all have the same Ly value. So we will say 5,800, 5,800, 5,800. So this means panel A has a horizontal dimension of 4,500 and a vertical or Ly dimension of 5,800. So, and then again, we need to input the value of our slab thickness. So we can say, let's call that slab underscore slab, okay, slab H. And that will be equal to, so 150. And then we can add the units by doing hash, and that will be mm. Again, we can add the units to this. We can do mm. Right, now let us input the value of the dead load of the slab and then the live load as well. So for the dead load, let's call it dead underscore L, and that will also be a range, so 2 square brackets. And then for panel A, so the dead load is 7.1 and the live load is 2.5. It remains the same for panel B and C as well. So we can say 7.1 comma 7, or since it remains the same for the 3 panels, we can just say 7.1. And then again, for the live load, let's call that Li. Let's call that live load, live underscore L. And that is 2.5 kilonewton per square meter, 2.5. And then let's add the units. So that is kilonewton per square meter. And let's add, we can copy this and paste here. Again, we need to enter the beam dimensions. So enter the depth of the beam as well as the width of the beam. So we can say B or beam underscore H. Beam underscore H will be equal to, again, we are going to use a range to specify the beam depth for each panel. So for panel A, the beam depth is 450 and it remains the same for the other panel. So we can say 450, 450, 450. And then we'll do the same for the beam width. So we can copy this and edit. So change this to beam width. So beam B. And then the width for the 3 beams is 250 mm. So we'll just change them. And then we'll add the units. So hash and mm and then hash. So that is all the input parameters. Now for the cover, we'll do that later on. So we've been able to input the parameters of our design. Now we are going to write a code to return the LX and LY for each panel, where the LX is the short span and LY is the long span. So we are going through the panels, and then for each panel, we would identify the short span, which is the LX, and then the long span, which is the LY. So let us comment that out to tidy up our work. So we can say hash again, and then we will write, so find LX and LY for each panel. So now to do this, we are going to use what we call a loop. So a loop is basically going through a series of functions or items and then doing a calculation or returning some values. So we are going through this panel, return the long span and then the short span. And looking at panel A, we know the long span is 5,800 and then the short span is 4,500. But in some instances, the long span will be here, say 5,000 or 6,000 even on this side here, and then probably you can have 4,500 here. So we are going to write a code to return the LX and then LY, where LX will always be the short span and LY will always be the long span. So to do that, we are going to use a for loop statement. So we will do for. Now we are going to assign a variable to the LX and then the LY. So we are going to say for I and J in LX and LX LY. Now